question says a rock is dropped from rest from the top of a 60-meter tall building. How far above the ground is the rock? 1.2 seconds before it reaches the ground. Okay. So what I can do in this question is I can draw the situation. Assume this is the 60-meter height, right? And this rock is just sent here, which is, it means u equal to 0. It's just dropped from rest, and this rock will reach, this is the ground level. Okay, and we need to find out how far above the ground is the rock. 1.2 second before it reaches the ground. So the first thing that we can do is we can calculate the total time it will take to reach till the ground. Okay, so for total time taken by the rock to reach the ground, so we can use the second equation, which is s equal to ut plus half gt square. In this case, since it is started from rest, so u is 0, so s will be half. G value we are taking 9.81, and t square we don't know, we need to find out this t, which is the total time. S is given as 60, so I am putting as value of s as 60 here. So this t will give us a value of 120 upon 9.81, which will be approximately equal to 3.50 seconds. Right, now we know that to travel from here to here, it will take time equal to 3.50 seconds. Right, now it is saying that we need to find out the rock's position when it was 1.2 second above, right? So if we consider that time, like I am breaking this total t time into two parts. This is t1 and this is t2, right? This t2 time is the time 1.2 second as given. So this t1 we can directly find out as 3.50 minus 1.20. So this will give us a value of 2.30, right? So this will give us a value of 2.30 seconds. So t1 I can write as 2.30 seconds. So we just need to find out the position of this rock when it has traveled 2.30 seconds. So I can again write the equation as s equal to ut plus half gt square. U is 0 as already given, so the new s I'm writing it s1. S1 is half into 9.81 into t square, which is 2.30 square. So if we calculate this value, this will be 25.9 meter, and this will be approximately equal to 25.9 meter, right? So see, this 25.9 meter is the height when it has moved till this position. From here to here it is 25.9, and it is saying that we need to calculate how far above the ground, so we need to find out this distance. So what we can do, we can directly subtract the total height, which is 60, minus 25.9. so I'm writing here, so height above ground will be 60 minus 25.9, which will give us a value of 34.1 meter. So this is our final answer.